if you look at what happened, what was coming from the generation before Lucas and the wave of SGE models, you had old style Keynesian models. So those were used to think about the effects of fiscal transfers. You had the so-called transfer multiplier in these models. So if you spent money, people had rule of thumbs where they would spend some of that money immediately. But in those models, this was a static analysis, so you couldn't think about the effect of excess savings on future activity and inflation, right? You could think that some of the transfers would be spent right away, but then whatever was saved was not later spent, and there was not a connection over time. And so neither the kind of modern macro models with recurrent equivalence nor the old style Keynesian models could capture this very important phenomenon that after fiscal transfers, you have better balance sheets and prolonged high economic activity, right? And so this created a space for a new paradigm to do fiscal policy counterfactuals. So models of behavior that could give rise to this excess saving phenomenon, where people have sort of target amounts of savings. And so because of a transfer, they save in excess of their target, then they want to spend that down. On the monetary policy side, if you look back 20 years ago, you had also kind of a very different situation from what is today. So on the monetary policy side, the consensus was you should use monetary policy for stabilization at the aggregate level, but you should not think about the distributional effects of monetary policy, right? So the idea is, suppose you cut interest rates, that will help the borrowers, that will hurt the savers, but those are not effects that the central bank should think about. In fact, the central bank should just be thinking about what are the effects on economic activity in total. And if you want, redistribution is a bit of a sideshow, and that's best left for fiscal policy, right? So there was sort of a clear separation where monetary policy was used for aggregate stabilization and fiscal policy was used for distribution. And we just saw actually fiscal policy has stabilization effects. And now I want to talk about how monetary policy has distributional effects. So the view of central bankers was basically this, that these effects could be largely ignored. They maybe existed, but they were not their role. And this was underpinned by a paradigm in macroeconomics, which is representative agent paradigm. We just use models in which there's only one decision maker. And so we don't have to think about the fact that there is, some people say some savers, some borrowers. Instead, we just think of somebody who on average doesn't have any saving or borrowing. Now, in central banks, after 2008 especially, there was an increasing recognition of the limits of this view and desire by policymakers in central banks to start addressing those issues. So this was both recognition that there was a lot of redistribution between borrowers and savers anytime you changed interest rates. And for instance, during the 2008 cycle, interest rates went down a lot. And so there was a lot of debates over whether this was hurting savers that were living off investment income. And so now the returns were lower. But at the same time, also a discussion of whether maybe this was actually really helping savers because asset prices were high. And, this idea that both monetary policy, low interest rates, and also quantitative easing was boosting asset prices, which was disproportionately benefit the rich people, right? So recognition that this was important in central banks kind of created a space for academics to come in and help think about these distributional effects. And if you look at what happened today, so this is Isabel Schnabel. She's a member of the executive board of the European Central Bank. She recently said, in the Monetary Policy Strategy Review 2021, we now analyze the interaction between income and wealth distribution and monetary policy as part of the way they think about setting monetary policy. It's kind of a core of the way they now set monetary policy. And this is completely different from what you could have read 20 years ago. So just recognition of that these effects matter. And they say it explicitly, distributional effects matter for monetary policy transmission, and they're part of the analysis. Okay? So what happened, in the meantime was the development of this new paradigm for monetary and fiscal policy, which is sometimes called HANK, so heterogeneous agent new Keynesian models. And so what are those models? Well, they have some property of old models and some property of new models. So they're micro-funded, like in modern macro models, right? So they're robust to the Lucas critique. They have a well-defined welfare objective. Everybody's maximizing. Markets are clearing. Okay, so you have the discipline from standard general equilibrium. Some of these models have rational expectations, so you have the discipline from that as well. Not all models have rational expectations. But the key thing is that either way, they're non-Ricardian, right? So they're non-Ricardian models. There's sources of frictions, typically borrowing constraints and precautionary savings, that create departures from the Ricardian equivalence result. And so as a result, fiscal transfers do affect economic activity and inflation. And those models behave similarly in many ways to old Keynesian models. In particular, they have these effects of fiscal transfers on activity, right, which was like in the old Keynesian models, but they take dynamics into account. So now you can have things like the transfer is partly spent and partly saved, and then the savings later affects economic activity. Right? And then finally, a very important property of these models is that they explicitly model the two-way feedback between fiscal and monetary policy and distributions. So what do I mean by two-way feedback? I mean, when say monetary policy changes, that affects the distribution. It redistributes, say, between borrowers and savers. But then that redistribution on its turn affects the aggregate effects of monetary policy because the redistribution is not neutral. So say borrowers increase their spending and savers cut their spending, but borrowers increase their spending by more than savers cut their spending. So in total, you have a boost of activity. And so that then affects the aggregate effects of monetary policy, and it affects what monetary policy wants to do, right? So you have kind of a whole loop between policy and distribution and policy. Now, today, if you look at central banks, most of the central banks, I haven't actually talked to my colleagues in Argentina, but I assume that they do as well. Certainly, Bank of Chile has a team, lots of other central banks in Latin America, lots in the US, obviously the US, a lot in Europe. They have teams that develop these models, right? And the reason is because we talked about, well, they're very useful, both in terms of correctly predicting the effects of things like fiscal policy and monetary policy at the aggregate level, and also that they allow you to study the interaction between the policy and the distribution, which is something that the central bankers care about. So that just really created a lot of space for doing these models inside central banks. And this is actually also slowly diffusing to fiscal policy institutions. So this is in French over here, but this is a team that's working together with the fiscal policy makers in France to develop a model called Sapre Hank. It's a Hank model to study the effects of fiscal policy as they are setting the budget. So basically now it's slower because for various historical reasons, there's fewer economists that have PhDs that are working for fiscal policymakers, but it's also happening. So also for fiscal policy, we're basing the decisions on these types of models. Okay, so what I'm going to do in this presentation, for the rest of the presentation, I'm going to basically take stock of the progress in this literature of the past decade. So I'll show you what a canonical model looks like in this literature, and then I'll show you some core results for both fiscal and monetary policy. So what do we learn from writing these kinds of models? and then I'll talk briefly about some bunch of extensions and some open questions. And like I said at the beginning, I'm happy to take questions at any time. So if you want to interrupt me, just feel free to do that. Or then at the end, we can sit down and, do questions and answers. Okay, and then in the process, I'm going to illustrate the usefulness of a so-called sequence-based approach to macro modeling. So at the same time as these models were being developed, so on the concepts, trying to address these big issues like excess savings and distributional effects of monetary policy, at the same time, we realized some of the older tools that were used for DSGE modeling, so things like state space approaches, were kind of not super well targeted for studying these models. So together with my co-authors, and now a lot of other people are using a new set of tools. It's called sequence-based. So I'll talk about that as well, because it's very natural coming in with the way the models are introduced. Okay, and so this is based on a bunch of papers I've written, especially with my two longtime co-authors, Matt Rogney at Northwestern and Ludwig Straub at Harvard. And then I have a lot of other former students and co-authors or students of my co-authors that are working with me on this. And if you're interested in learning more, there's a chapter that's forthcoming in the Annual Review of Economics that actually has the same title, Fiscal Policy, Monetary Policy with Heterogeneous Agents. And so that's a chapter that will come out in August. Okay, but it's actually already available online and it's on my webpage. So you could read more about this literature and of course get a lot of more references. I'm not going to be able to talk about all of the references, but there's a lot more in that paper. Okay, so any questions so far?
No.
Okay.
Go ahead.
Okay, so let me talk about then Hank. Okay, so Hank is, like I said, it's a merger between two traditions, so heterogeneous agents and New Keynesian. So let me kind of explain what the main ingredients are of this model. So this is a model of households, people that are facing idiosyncratic risk to their productivity level or their efficiency level. So this is the E. So he's following a Markov chain in this paradigm. So you can have, high income, you're very productive some time, and then maybe you get unlucky, maybe you lose your job, maybe you have an accident, your income falls. And so people are worried, they have high income, they're worried about their future prospects, maybe losing their job, and that's going to create a motive for saving. So their decisions to consume and save are going to be based on what their prospects for future income are in the form of this E. And so what do? I mean, they, as in standard macro models, they try to maximize the expected value of the utility of consumption minus the disutility of labor, subject to a budget constraint and also a borrowing constraint. So the budget constraint says they have access to this asset A, and asset pays a certain interest rate R, and they also get their labor income. So what's the labor income? Well, it's post-tax, so there's a tax rate tau on your labor earnings. That's the wage times number of hours you work times the E. So think if you have E of 1, you have kind of the average income in the population, you're going to get the average wage. And then some people are 10 times more productive, they get 10 times the wage. Some people are much less productive, they get much less. Okay, so E scales your labor income. And so E is idiosyncratic, it's specific to an individual, whereas the wage, well, that's aggregate. That's the common wage that's paid per efficient unit of labor in the economy. Okay, so that's the key, the core of the model. So this is a model that is similar to maybe if you've heard of the Ayagari model. That's basically this model. Here I have N that is potentially chosen. I haven't told you what it is, but I'm actually in a minute going to say N is not some choice of the individuals, because due to frictions in the labor market, they're actually not choosing their hours. Instead, their hours are going to be chosen or dictated by the aggregate labor market conditions. So this is going to be a model with sticky wages. Now, fiscal policy. So fiscal policy here sets the tax rate. It also has a certain amount of government spending. And finally, it has some debt. So this is completely standard fiscal policy that decides on the tax rate and government spending, as well as potential deficit financing. So using B, debt, to finance any gap between tax revenue and spending. And so here you have this heterogeneity, right? You have all these agents, they're potentially working different hours. So there's NIT, and then they're collecting per unit, they're collecting tau times the W. So that's the labor income that they're collecting. And then they're spending G. And then any gap between government spending and tax revenue, that's going to be financed by debt. Right? So debt tomorrow is 1 plus R times the B today, plus the G minus the tax revenue. And the government here, I'm not specifying more. I'm just saying, the government can set any path for government spending and taxes. It just has to be compatible with an intertemporal budget constraint. So you cannot run a Ponzi scheme. You cannot run debt forever, but you can use deficits to finance any gap between G and T. Okay, so that's the government, the fiscal policy. Now, what about production? Right, so this is like classic general equilibrium model. I'm specifying all the pieces of the model. So just talked about households, talked about fiscal, talked now about production. So production here is out of labor. There's just one-for-one transformation between total aggregate labor N and total productivity and total output Y. And we have perfect competition in the goods market as well as flexible prices. So because of that, the real wage is 1, right? Remember, Y is just equal to N. So that means that 1 unit of labor produces 1 unit of output. And so the optimality condition for the firm is actually to set the wage to 1, right? Which is the marginal product of labor. Okay. So that's so far completely standard macro model that has heterogeneous agents. So this is in this tradition of Deaton, Carroll, Bewley, Haggett, Ayagari. Deaton and Carroll were these models of precautionary savings that were just focusing on households. And then later, Bewley, Haggett, and Ayagari, they extended that to general equilibrium. But those were neoclassical general equilibrium models, right? And so if you look at the model that I wrote down, and you also had a flexible choice of labor, then you would actually have something that looks a lot like the Ayagari model, which is a neoclassical model. So what is different here is that we'll have nominal rigidities, okay? And so that's coming from this new Keynesian tradition. And the assumption here is going to be one of sticky wages. So not sticky prices. Remember, prices are flexible, but sticky wages. So that's actually more like in the Keynesian tradition of having wages that are rigid, nominal wages, rather than the more modern New Keynesian tradition started usually from sticky prices. Now, one thing we realized as we were working in this literature is that starting from sticky prices creates a lot more complications and interactions with heterogeneity than starting from sticky wages. And so I'll show you how easy the model is with sticky wages. So how easy is it? Well, you just say labor is rationed. So households are off their labor supply curves. They're not choosing their N here, right? Remember, I have this max over here. You don't choose your N. Instead, your N is given by aggregate labor, which is aggregate Y here. Okay, so this is like it's like demand determined labor. So there's a certain amount of economic activity in the economy. And in the short run, when there's more activity, the firms have more labor demand. They just hire more workers. And so everybody is just supplying more labor. Okay, so that's the assumption. That's, of course, quite simplistic. You can try to think about extending this model to think about unemployment, for instance, where it's not that everybody works more when there's a boom, but instead it's like some people work more. Maybe people that were unemployed now become employed. That would be a slightly, an extension of this model that is easy to think about. And so at the same time as you get kind of demand determined labor, so this is like on the output side, you also get inflation. Inflation, as in the standard New Keynesian tradition, that's going to be determined by a Phillips curve. And you can derive the Phillips curve from inside the model. So just say, what do people do when they can't reset their wage? Well, they're going to ask for a raise to the extent that the marginal disutility of labor is high relative to the amount that you can get by taking your post-tax wage and turning that into consumption, right? The marginal rate of substitution, in other words, between labor and consumption is high relative to the wage. That's a time when workers are working too much relative to their optimum. They're going to ask for a raise. And the process of asking for raises generates wage inflation. And then remember, there's flexible prices here. So there's perfect pass-through of wages to prices. So then wage inflation creates price inflation. And so that's the process by which, in a model like this, high economic activity leads to high inflation. Right? So I'm just kind of going quickly here, but this is completely standard in the New Keynesian tradition on the wage side. This is the standard wage Phillips curve for New Keynesian model, just here adapted. You see this integral over here, that's the heterogeneity. So it's just adapted to deal with heterogeneous agents, because now there's a lot of people and some of them have different marginal rates of substitution. Okay, so monetary policy here sets interest rates, and we're gonna, for simplicity, just assume that it uses a simple rule for the nominal interest rate, which is R plus tomorrow's inflation. So this is like a Taylor rule with a coefficient of 1 on expected inflation. So it's not exactly the standard rule, but it's a much simpler way to analyze the model. So we can start from there and then ask a question later, what happens if it's a standard Taylor rule instead, okay? But it's just a rule for monetary policy. That's good to simplify our life for thinking about the transmission mechanisms. And it's not very costly in terms of a kind of a simplification, because in practice, inflation can be pretty sticky. So in other words, the kappa is pretty low. And so if kappa is very low, a rule for the nominal interest rate that's like this is like, if kappa is very low, it doesn't matter that what the rule is really. Is what's important is that when nominal interest rates fall, real interest rates fall. And they tend to fall by the same amount because inflation is very sticky. Right? So that's not a big simplification in a world where inflation doesn't respond much to activity in the first place. Okay, so goods market clearing, right? So as in the standard general equilibrium tradition, of course, we have optimizers, all agents optimize and markets clear. So what's good market clearing here? Well, this is a model without investment and without an open economy. So the only two components of aggregate spending are government spending and consumption, right, from the expenditure side of GDP. And so that has to be equal to production, which is the production side of GDP. So that's the market clearing condition. And that's it, right? So that was just 5 minutes on the model, and you see it's a very simple model. Especially if you are familiar with models from this tradition, heterogeneous agents, and you have some familiarity with New Keynesian models, you'll see this is a completely natural merger, and it's the most natural thing you could do, thinking about bringing these traditions together. But as I'm saying over here, the literature took lots of detours to get there, because it wasn't obvious at the beginning that this would be the natural place to start. So like I was hinting at earlier, because the New Keynesian models had been developed more thinking about price stickiness than wage stickiness, a lot of the early papers in this literature were using price rigidities, not wage rigidities. So that's an example of, that created a lot of issues with the models. And then we realized, no, never mind, we shouldn't do this. And so we kept coming back until we found a model that I'm calling the canonical model. It's just the simplest possible way you can merge these two traditions that gets you somewhere. And so I'm going to show you now what you get from it. Okay, but before I do that, I want to talk about these methods a bit. So the idea of analyzing models in the sequence space. So you can look at the aggregate equations that I have so far. Right? So I have a simple equation that just says actually total tax rate. So sorry, this is a definition. I'm going to write the total T as tau times the Y. That's total tax revenue. Right? That's just a definition. What is total tax revenue? Product of the tax rate by total Y. Remember, I'm just taxing labor here, but then also GDP is just labor. So that is total tax revenue. And then also N equals Y, remember? So amount you're working is equal to Y. Okay, so what does that mean for households? I mean, they take this as a given. They know, they're going to know in equilibrium, they'll know what the sequence of production is in every period. Right? And so we're going to give them perfect foresight. It's like rational expectations. Without any aggregate risk, it's going to be perfect foresight. So they know what production is in every period. So they know how much they work in every period. So they know this. And also they're going to know what the taxes are every period. So they'll know Y minus T. And then it turns out once you do the substitutions with the other equations that I have, that their personal income, their own income, is just the product of their individual E, which is idiosyncratic and varies, times post-tax income, aggregate post-tax income, Y minus T. So if you want to know what's your income, you just look after taxes, you just look at what is aggregate income after taxes, Y minus T, multiply that by your E, that gives you your own individual post-tax income. Okay, and if you look at this problem, you realize actually every individual's consumption decisions here in this world only depends on what happens to Y, what happens to R, and what happens to T in the aggregate. Those are the only things that matter. And actually, it's even better than this. The Y here is just a term that shifts the maximizer, but it doesn't actually affect decisions, right? The decisions, it's like a constant term in the maximization problem. It doesn't affect at the margin the decisions. So the only two things that matter for the decisions are R and Y minus T. Okay, so what does that mean? For individual decisions, only thing that matter are these path of aggregates. So then for aggregate decisions is the same. You know, the aggregate consumption here is, if I go back for a second here, if you think about aggregate consumption, that's a complicated object. That's the aggregation of the consumption decisions of everybody in the economy according to the distribution of people in the economy. And that distribution is an endogenous object. It moves with people's savings decisions. It's some complicated object. But what we know is that starting from anywhere, if people know the sequence of R's and Y minus T's, they're going to make certain decisions, which will lead to them to save. So the whole distribution will be a function of Y and R, Y minus T and R. And so then, household decisions are only affected by these aggregates. The distribution is only affected by these aggregates. So the aggregate consumption is just affected by this. And so we're going to call this a sequence-based function. This is a function, this is like a function that has indices as time, right? So this says consumption in period 0, period 1, period 2, and so on, as a function of the whole sequence of expected interest rates and post-tax incomes. So it's a complicated function, right? But we have reduced the problem a lot in that we've realized that these are the only two things that matter. So R and Y minus T are the only two things that matter. And so we can substitute this function back into the goods market clearing and realize, okay, well, what this gives us is an equation that says at any point in time, GDP, which is production, must be equal to spending, which is G plus the C. But the C in turn depends on the Y minus T and the R. So notice we have Y on both sides of this equation. And actually, it turns out, the way I formulated the model, that fiscal policy and monetary policy are the only two things that I don't know here in this equation. If you give me fiscal and monetary policy, this is a set of equations that determines what output is. So in other words, the way to solve the model is to say, give me fiscal and monetary policy, and then solve for the Y that satisfies this fixed point problem, where at any point in time, T, yt must be gt plus ctr and y minus t. Okay, so if you know the c function, then this is a functional equation you can solve for the y. And that's a sequence space function. So it's a function in a space of sequences, because you need to know the whole sequence of r and t's, and then you're looking for the sequence of y's that satisfies this equation. Okay? So that's it. Basically, why is this useful, the sequence space? Well, because we can reduce complex models with heterogeneous agents to just looking for solutions to equations like these, that are equations in aggregates. Here, in this case, the unknown is aggregate GDP. Okay, so let me turn to fiscal policy. So what do we learn from this? Okay, so let's just suppose that monetary policy sets a constant real interest rate. So then the r drops out of the equation that I had before. I already know what that is. That's a constant. And I could just focus on this equation over here, which is a fixed point in y given g and t. So how do we proceed from this? Well, just as in standard models in DSGE, we linearize the model. So we say, okay, we're going to look around the steady state where y, t, and g are constant. We're going to think about shocks to government spending and taxes. And then we'll ask, how does output respond to these shocks? Okay, so fiscal shocks in this case. And okay, so we can linearize this. And so because it's a set of equations in time, when we linearize, we're gonna have vectors and matrices that are involved. Now these are infinite dimensional vectors and matrices. So there's a little bit of advanced math you need to know. You need to know some functional analysis, which is basically linear algebra in infinite dimensions. But it's not really that different from what you know from, say, linear algebra, right? So there's a matrix M, multiply that by the vector T, that gives you the effect on consumption to first order from a change in taxes. Similarly, there's a matrix G, and there's a vector G, that's easy. And then finally, there is, on the right here, there is, you multiply the matrix M by the vector of output that gives you the response of consumption of a change in output at different dates. So we call this the sequence-based Jacobian. It's just the Fréchet derivative of the c with respect to the y. And so the way you want to think about it is, it's the consumption response to a change in y. So that looks like a marginal propensity to consume, but it's dynamic, it's over time. So we ask questions like, what's the consumption response in year 5 to a transfer in year 0? Okay, so that's the consumption response in the future to a transfer in the past. And you can also look at or think about what's the consumption in response in year 0 from an income change in year 5. So that's an anticipation response. So this is like, people know that they're going to get richer in the future, and they can increase their consumption now because they can borrow. So it takes into account all the potential dynamics, and these models have complex savings and spending dynamics, and all of that is going to be encapsulated in this M matrix. So once you know this M matrix, and you look at this equation, you say, well, hold on, that looks a lot like the Keynesian cross, right? So Keynes and then later Hicks and so on, they formalized this idea of a Keynesian cross, which is how does output respond to fiscal policy? And then they had an equation that looks like basically like this, except it's not a vector equation, it's just a scalar equation. So it says, well, in equilibrium, there's a feedback between income and spending, and people spend at the margin in response to their income according to their marginal propensity to consume. So if I want to know what's the effect on output of a change in government spending or taxes, I can just solve this equation, and that's going to give me the output response to fiscal policy. Right? That was in the Keynesian cross, right? And this is the same, except it's dynamic, it's over time. Right? The Keynesian cross was widely criticized because it didn't take into account the dynamics. And actually, once we worked out the simplest way of setting up a model with heterogeneous agents and sticky prices, we realize actually we find the Keynesian cross again is just a much more it's just a more complicated object mathematically because it involves infinite dimensional matrices and vectors, but it's conceptually the same, right? It just says if I increase government spending, that's going to increase production. Production increases income. People spend out of income. And so we're going to get a term both from the GG, but also a term from the DY here. Similarly, if I raise taxes, well, that's going to put downward pressure on consumption because people will reduce their consumption when they know they're getting taxed. And so raising taxes is bad for consumption. That's this first term. And then if it's bad for consumption, in equilibrium, that will lower people's incomes, and less income will means less consumption again. And so you're going to get a feedback through this term. Okay, so that's just the same economics as in the Keynesian cross. Okay, and so we call it the intertemporal Keynesian cross, and we formalize a lot of these arguments and also a lot of the math that comes with this in this paper that's now published in the Journal of Political Economy. Okay, so what's the benefit of this? Well, a bit like in the Keynesian cross, people can visualize and understand what these M's are, right? These M objects, they're conceptual mathematical objects, but they're also very tangible in terms of the micro data. Because if you think, for instance, of the first row of this, the first column of this matrix, it's the MT0. That is the average path of household spending after one-time transfer. And so this is something that you can compare to the data, right? Because we actually know from data, here I have data from Norway, we know what happens when people get a transfer. They tend to spend a lot of that transfer when they get it, but they also save a good amount of it. And we know this very interesting property that there is elevated spending out of past transfers years after you get the income, right? So this is an evidence from the lottery study. So this is tracking people's consumption over time after they win the lottery. Suppose they get $100 in the lottery. They're going to spend $50 in the first year, almost $20 in the second year, almost $10 in the third year, and then it'll go away. Okay, so they basically then exhaust the $100, so they don't have any more to spend. So there's this dynamic pattern of spending in response to an increase in income, and that dynamic pattern is something that the heterogeneous agent model is able to match. Okay, we can calibrate that model to match this dynamic pattern. And that is very different from the earlier generations of models. So if you think about the representative agent model, that's a model that satisfies Friedman's permanent income hypothesis. So if you give this person in the lottery, they basically save all of the lottery and then they just eat the returns on the lottery. So they annuitize. And so what that means is that their consumption is very, very low. It's kind of higher forever, but very low on impact, right? So you cannot explain the marginal propensity to consume in the data. That's a well-known deficiency of representative agent models. They cannot explain the MPCs in the data. But also, if you think of it, the old-style Keynesian models, which the newer version of that was the so-called two-agent models, like tank models or saver-spender models. So in those models, you're either a saver or you're a spender. And so if you get a transfer, you either spend everything right away or you save everything and never spend again. And so even though you can explain why there is so much spending on impact, you cannot explain the persistence of spending. Right? You cannot explain why people, after they get the lottery, will still spend $20 of that lottery next year. Right? That's a unique property of heterogeneous agent models that was not in any of the earlier generations of models. Right? Okay, so what about the effects of fiscal policy? So if we solve for the effect of balanced budget spending, so suppose that you increase government spending and taxes at the same time, well then the result is that output, which is shown here on the right, is increasing with government spending 1-for-1. And that's actually true in the heterogeneous agent model, the representative agent model, and the two-agent model. Those three models have the exact same predictions for balanced budget fiscal policy. Okay, so why is that? Well, that's because of an old result from the ISLM literature, actually, so from the Keynesian cross. And the reason is, well, if you do balanced budget fiscal policy, suppose you increase government spending, yes, you're going to increase people's incomes, but you have to raise taxes to pay for the government spending. And you raise taxes by the same amount as you increase their income. So for people's, their post-tax income is unchanged. If their post-tax income is unchanged, their consumption is unchanged. So then there's no effect on consumption. And so therefore GDP rises 1-for-1. So that logic, which was true in the Keynesian cross, is actually still true here. And like I said, these models, even though they have a lot of modern features, they're not that different from old style models in terms of their intuition and economics, right? So this is one example of you find the same thing. In at least the case of the model I specified, you can of course think about deviations from that. For instance, what if at the margin, the taxes are paid by the rich, but the income is earned by the poor? In this case, you have a redistribution between the taxpayers and the income earners, and that will change this result. It will make fiscal policy expansionary in this case. So this is for spending multipliers. Now, but what about transfers? So suppose that you do a transfer. So you don't change government spending, but instead you lower taxes today, and you announce that you will raise taxes in the future. So this is the kind of thing that Ricardian equivalence says should have no effect. You lower taxes for today, raise taxes in the future in a couple of years. People understand this. They save everything, and then there's no effect on consumption. Now, in a two-agent model or in the old-style Keynesian models, you knew that this was not the same, because when you lower taxes today, there's some people that are borrowing constrained, or some people that are completely hand to mouth. They just spend everything. So if you give them money, they spend everything. So that increases their consumption. But remember, 2 years down the line or 3 years down the line, you're now raising taxes. Well, for these people, if you raise their taxes, that lowers their income, they spend less. So the pattern that's predicted from giving people money today, lowering their taxes, and raising taxes in the future is a boom and then a bust. It's like high GDP today, low GDP tomorrow. That's the old Keynesian model. It basically is completely static. So look at what's happening to post-tax income this year. That's what's happening to consumption. Now look at what's happening to the heterogeneous agent model. On the other hand, in that model, if you give people money today and you say you'll raise taxes in the future, what do? They spend some of that, but they also save some of it, but they're planning to spend it in the future, right? Remember this pattern. It's from here. They're spending still in the future. They're richer. So because they're richer, they actually have saved some of the money to pay for the taxes. And so they don't need to lower their consumption. In fact, there's a consumption income feedback. So as people feel richer, they spend more. They feel richer now and in the future, so they spend a lot in anticipation. That increases other people's incomes, and so on and so forth. And so you get an amplification, you get even more spending, and you don't get the bust, you get persistence. And so remember when I was talking at the very beginning about the effect of excess savings. So people thought in 2020 you give these transfers. By 2023, the transfers are gone. If anything, monetary policy is tightening. This is kind of bad for people's incomes. But you have the effect from the past savings, and that is creating persistent economic activity. It has all these persistent effects. So this is this blue line. And so this is kind of a unique property of these heterogeneous agent models, that you can get persistent effects of spending from past transfers. Okay? So the bottom line is fiscal transfers are more powerful and they're more persistent under the heterogeneous agent New Keynesian models, the Hank models, than they were from any other models before. Now, one perspective on this that's interesting is a distributional perspective. So one way to understand what's going on here is actually to think about what's happening to the holders of government debt. So this is a general equilibrium model in which market clearing on the goods market is equivalent to market clearing in the asset market. So instead of thinking about who's spending, we can think about who's saving. And when the government issues a transfer, they'll finance it with a deficit, right? Remember, this is not changing government spending. It's just we promise to raise tax in the future. So we're financing it with a deficit. We're issuing some debt and planning to repay that debt in the future. Now we can ask, oh, who's holding the debt? So this diagram over here, which is from a paper I wrote called Trickling Up of Excess Savings, is kind of a representation of what's happening here, which is, look at the COVID transfers. They were targeted to the bottom of the income distribution. So the poor and the middle class, they got the transfers. They spent some of that, but they also saved some of that immediately. And then the saving got recycled into purchases of government debt. So at the very beginning, who holds the debt? It's the poor and the middle class. They're saving. But over time, they spend down their saving, and so they're selling their debt. And who are they selling to? Well, they're selling to the rich. They're selling to people who are not spending as much. So they now are purchasing the government debt. And then as that process goes on, even the rich start to spend, and they keep spending. And then the debt ends up so they're selling the debt, and it's ending up in the hands of the very rich, what we call the top 1% here. This is just a depiction of what's happening in terms of the distribution of holdings of government debt. Like as time goes, we say the excess savings are trickling up towards the top 1% who have very low marginal propensities to consume, and so they are more likely to hold on the debt. And so this process is a very slow process, and it's a process that explains why there's so much persistence in the spending, because the rich keep spending, and even the top 1%, they have some marginal propensity to consume, and so over time, the composition of spending is shifting towards the top of the distribution, which is where the debt is being held. So that's kind of an interesting perspective on it, and it shows you why heterogeneity matters here. Like we couldn't get the persistence without the distribution. So the distribution is central to understanding the persistence property of government spending. Okay, so let me talk briefly about monetary policy because I want to leave time for questions at the end. So monetary policy is also very interesting to study here. So you can study it with the same types of tools as I studied fiscal policy. Instead of being a shock to the T and G, it's a shock to the R. And there's another derivative, another Jacobian, which is the derivative of C to R that feeds into this equation here, just like fiscal policy does. And so it also gives us kind of the initial impulse to aggregate demand. Say you cut interest rates, people want to spend more today, less in the future. That creates an impulse to aggregate demand, which then can generate the aggregate effects of monetary policy. And early in the field, the idea was that maybe we could use this to solve the so-called forward guidance puzzle. So suppose that you announce an interest cut in the future. Well, because people have borrowing constraints and so on, maybe they're not going to spend more today. And so perhaps actually you could explain why what the Fed was trying to do during the Great Recession, which was to kind of announce that the interest rates were going to be low for a long time, that didn't appear to have much effect on activity. And these types of models could maybe explain it. So this was the idea. And this is for thinking about this term over here. Okay, with borrowing constraints, if I announce future lower interest rates, that's not going to affect consumption that much today. Right? So forward guidance puzzle. But actually, in practice, so this is true in so-called partial equilibrium, so holding the Y fixed. But remember, there's a fixed point between spending and income. Right? So if you look in general equilibrium, actually, that's no longer true. In general equilibrium, you do get still a lot of spending impact from an increase in future interest rates, which here is like in 20 years. Right? And the reason is, well, people are as there's a few people that are spending, and those people are raising other people's incomes, and those people have high MPC, so they're spending again, and so on and so forth. So you start from this blue line here, holding income constant. You end up in this blue line here, which is once incomes have adjusted, right? So today we no longer think that you can solve the forward guidance puzzle with Hank because of this problem. It's basically, as you put more people with more MPCs, any increase in spending will result in a lot more income, and so a lot more GDP. So you may not be able to solve the forward guidance puzzle. Okay? And the basic idea is there's sort of two competing effects of marketing completeness. Yes, people respond less to interest rates, but they respond more to income, right? And so sometimes people call this the direct effect of monetary policy is lower, but the indirect effect is bigger. And Hank makes the indirect effects of monetary policy larger, but it may not change the aggregate effect of monetary policy. And so one of the early papers in this literature, a very influential paper by Kaplan, Moll, and Violante, was making that point, right? That it sort of changes the composition, makes these indirect effects bigger, but it's not a point about the aggregate effect. We don't actually know what the aggregate effect. You have some benchmarks, like this paper by Verning, in which the aggregate effect is actually identical to representative agent. So contrary to fiscal policy, where the aggregate effects of fiscal policy, especially transfers, are very different, in monetary policy, the aggregate effects may be quite similar, but on the other hand, the distributional effects are very different. So there's still some interesting angles from distribution, as well as from thinking about direct versus indirect effect. Okay, so just to conclude, canonical Hank model relative to standard model, balanced budget fiscal policy has similar aggregate effects, but deficit financed transfers are much more powerful and much more persistent than we thought before. Monetary policy has similar aggregate effects, but the transmission mechanism of monetary policy relies a lot more on these so-called indirect effects, as well as on distributional effects. Okay, so that's kind of like a takeaway from thinking both about fiscal and monetary policy. Okay, so just to tell you a little bit about what people have done in the field, going beyond this canonical model, people have thought about the so-called countercyclicality of income risk. So this is moving away from thinking that everybody works the same number of hours. For instance, there's unemployment in the model. So you have more realistic models of unemployment and unemployment risk. And you have this feedback loop in particular where anticipating a future recession creates income risk for people today, which then affects the recession today. So you get current recession from anticipation of future recession. So that's an interesting area of the literature. There's a literature that thinks about the maturity structure of assets and liabilities. So it thinks about long maturity assets. With long maturity assets, low interest rates create capital gains. Capital gains redistribute from poor to rich. That's an important effect in these models. And so you can start thinking about what's the effect of maturity. Similarly, you can think about the nominal denomination of assets and liabilities. So the model had real debt, but if you think there's nominal debt together with the inflation effects of monetary policy creates redistribution between borrowers and savers. And that also has effects on monetary policy. You can start moving away from marginal expectations, so incorporating behavioral effects into Hank models, and think about things like imperfect information or cognitive discounting. Like if you think that you want to solve the forward guidance puzzle, this is a promising avenue. You have estimated models. I've talked a bit about that, how in central banks, they're developing these models at a larger scale, so they have more complexity to be able to have better forecasting properties. And so those are models being developed in central banks today. And then there's all the open economy models. So this was, I was talking about closed economy, but of course, you can start thinking about open economy models too. And there you have interesting effects coming from, say, the distributional effects of exchange rate changes. Say some people borrow in dollars, some people borrow in pesos, to take the case of Argentina. And then when the exchange rate changes, well, that redistributes between those who hold peso debt and those who hold dollar debt. There's also current account implications of fiscal deficits, like twin deficit type phenomena, effects of energy price increases, which may come from abroad, on household spending and implications for fiscal policy. So although all those are kind of examples of applications of this framework for thinking about a lot of important issues today. Okay. Okay, so that's it for me, and I'm happy to take questions now. So just to conclude, this Henk model is like a new paradigm for the analysis of fiscal and monetary policy, and there's a lot of exciting results in the field, as well as a lot of ongoing developments, things I haven't talked about, like illiquid accounts, portfolio choices, asset pricing, optimal fiscal and monetary policy, and so on. Those are all like frontier questions that are generating a lot of research today. So I look forward to your questions and maybe to your future contributions to this area.
Okay, thank you, Adrien.
Thank you.
Questions? Can I start with a technical question? Oh, we have a question online. Carolina, can you get that?
Can I get it?
Yeah. But
Yeah.
my question is this: your equation 1 assumes the existence of a fixed point.
Mm-hmm.
Have you proven or have you given the conditions for the existence of this fixed point in this sequence space?
Yes, yes. So you have to have a certain contraction property for this M matrix, right? So which is over here. So you have to have its roots. So think of it as like the roots inside the unit circle. And so there is under certain properties, like M being positive everywhere, which typically it is, then you can show that there's a unique fixed point. Yes. Yeah.
Okay, and this contraction property is something you can assume it applies in every interesting case?
No, so there is cases where you get multiple equilibria. So in the canonical model, you can show the one that I showed you, you can show that it is contracting, but
Yeah.
then it's easy to construct examples in which it's not, like the countercyclical income risk models. So in those models, the M basically has this property that like any future increase in income has very strong feedback on today consumption. And then if that's big enough, it could mean that an expectation, it's like a sunspot, an expectation of an increase in future income is increasing consumption so much today that it becomes self-fulfilling, because then, consumption increases today, there's a big boom in activity that then increases spending tomorrow, and then that can kind of become self-fulfilling. And so there's actually a set of tools. So this is the sequence space, but in the sequence space, so in the state space, or like the standard models, you have these Blanchard-Kahn conditions, which are conditions for the uniqueness of rational expectations equilibria. So we have the equivalent conditions in the sequence space, which is called a winding number criterion, which is a criterion you can check, which is equivalent to Blanchard and Kahn conditions for state space models. So it's the same type of kind of analysis where you basically count roots inside the unit circle. Yeah.
Right. But then when you have, in those cases in which you have multiple equilibria, could your empirical analysis be hampered by that? In the sense that you may mistake one equilibrium state for another?
Yeah, I think that's a really interesting question. So the empirical analysis, the data that we use to discipline the model is just micro data. So in the micro data, if you want, it's kind of figuring out the elements of the M from the micro data. And so from the micro data, there's no threat to identification there, because it's like in an equilibrium. If I give if I give a single person some money, so it's not thinking about shifting equilibria. It's just saying within an equilibrium, if some person gets some money, what do they do? But it's true that then if we were to use macro data to discipline the model, like in these estimated models I talked about at the end, those estimated models, they would need to take into account the possibility of multiple equilibria. And so that appeals to certain techniques of you know, fitting models with multiple equilibria to aggregate data. And so that's something that hasn't really been done as far as I know, but that's a really interesting question.
Yeah, because actually you can see this Fréchet derivative as like kind of a proxy for a gradient, right?
Yeah, absolutely. It's a form of, the gradient would be the one dimension, and then this is like gradient for each.
In the neighborhood of an equilibrium. So it's a question, an open question then. So
Absolutely.
thank you for your answer. And let's hear there is a question of Manuel.
Manuel, ¿puedes silenciar? Ah, está.
Yeah. Thanks, Adrien, for the talk. My question was regarding, this is more general to the literature than your presentation, but you know that in Ivan's paper, you have like a more general structure for the borrowing limit. Like you have this type of agents that can have different borrowing limits, and that borrowing limit also can depend on some variables. So after that paper, I haven't seen that in other work in the literature, and I don't know if that is a computational problem to compute those type of models, or is it that it's not empirically relevant? I mean, if the dynamics are not as interesting, I don't know why literature hasn't gone on that path.
I wouldn't say that it hasn't gone on that path. I mean, it depends a little bit the setup. So if I look at, you know, the way this model is set up here, it's a model with bonds. So bonds, I mean, they typically don't have a borrowing limit that depends on the level of income, right? So this is more for realism. So if you say, well, if you're borrowing, you know, typically people will say you can borrow up to some amount, and then it's not the borrowing constraint relaxes when you know, changing. So for these kinds of situations, then it's more natural to have some A bar, or maybe this would be 0. And actually but on the other hand, there's two types of models when something like this can happen. So if you have collateral borrowing, so you're borrowing against collateral, right? So this would be maybe for a mortgage or a house. Then you will have something on the right-hand side of the budget constraint that depends on the value of the collateral. And perhaps under certain situations, the value of the collateral depends on the level of GDP. For instance, if say the ratio of house prices to GDP is a constant, then that would be an example where the borrowing constraint becomes more involved and a bit more similar, you know, to what the Ivan Burning paper has a general specification of what's over here on the right. And then another class of models, which actually is part of, not my presentation today, but what we have in the annual review paper, we have a version where people invest not just in bonds, but also in stocks. And actually, in the case where there's no bonds and just stocks, then you know, the stocks, they scale with GDP. And so then you do have actually exactly
like an endogenous
result. Because it's kind of like now the amount. So there's a capital gain basically you make when you invest in stocks, and there's some, say, lower interest rates which revalue the stocks, and so that actually is a situation which has the same properties as one of the results that Ivan is proving, where the A, you don't want to think of it as something that has a value that doesn't change over time, but actually its value is changing because the stock market is changing.
Yeah, right. Thanks.
Another question?
Can you hear me well?
Can you hear?
Yes, I can hear.
Okay, well, so my question goes around the limitations of the prediction capability of the model. For instance, I was thinking, I don't know, maybe across different countries, the preference differs, or the model sometimes behaves not as well. Or, for example, after supply-side shocks, maybe it's not as good as prediction for demand-side shocks. Have you found any limitations or some kind?
I mean, so there's two parts to your question. So one is, can we apply these models to think about other countries, and maybe it works better in some countries than others? So absolutely yes. So like I was saying at the beginning, the Hank models, they're being used in by countries everywhere, and so there's data on NPCs in different countries. The data is not as good usually, so some limitations are just the micro data is not yet available, but it's starting to be, and there's some evidence that the NPCs in more developing countries or poorer countries are higher. And what that suggests is then that the effects that are in these models, like these income consumption feedbacks, can be bigger. So we're not at the point yet where we can say, oh, these models are better fits for certain countries than others, because I think it's still early stages of development, but certainly there's some promise to even explain different responses to monetary or fiscal policy in different countries. I'll give you another example. Some countries have adjustable rate mortgages and some countries have fixed rate mortgages. And we know from the aggregate data that adjustable rate mortgage countries tend to respond more to monetary policy than fixed rate mortgage countries. And actually, that's a prediction of this model. So this model fitted to adjustable rate mortgages versus fixed rate mortgage countries. It will have bigger effects on monetary policy in adjustable rate mortgage countries. So that is a cross-sectional prediction of this model that is validated in the data. Right. So does that answer all your question? Or I think you had a second part to your question.
No, I think it's right. But maybe if there was another limitation that you can see, for example, for negative supply shocks, or
right. Yeah, you mentioned supply shocks. So today I just focused on demand shocks because that is really where the differences are more stark relative to the standard models. But because this is a model that inherits from the standard, RBC DSG tradition, it is very easy to add supply side shocks to these models. And the supply shocks will work, similarly to how they do in the RBC model. So in the kind of modern estimated models that I was talking about, there is both supply and demand shocks. And that's going to be important to match the co-movement properties of inflation and activity, for instance. So we know that, there isn't a perfect correlation between activity and inflation. That's usually attributed to a mix of supply and demand shocks. And so in a model like this, you definitely would want, once you start confronting it to the data, you want to have supply shocks as well as demand shocks.
Okay.
Another question?
Yes. Well, hi, Adrien. My question is about, you said that the model behaves similarly to all Keynesian models, but take the dynamics into account. And when I was reading your work, I immediately thought about this distributional featurings and also the different marginal propensities to consume. And my question was, to what extent can one relate the H-shaped Hank model with Kalecki Keynesian models, or these all broad post-Keynesian models, for example, those that are exposed in Lavoie work about the neo-Ricardian and Kalecki models with different marginal propensities to consume with them. working class people or capitalists?
Yeah, I mean, that's a very good question. I mean, you're right that there is also a tradition. So after Keynes, right, a tradition that developed that was a tradition that thought a lot about distribution, right? And so to some degree, the kind of the worker capitalist perspective and also the importance of different marginal propensities to consume along the income distribution, which was developed in these later Keynesian analyses, like Kalecki and others, has echoes here. Right? It has echoes here, but I would say that the main distinguishing feature is it's not so much on the themes. So the themes are very similar, right? Including on the distribution, but it's more that it really came from the tradition of micro foundations, and so that work has more. It's more robust to, say, the Lucas critique and to the types of issues that were pointed out, like some kind of consistency issues that were pointed out by the critiques of those models. Right? And so, not to say, this is not to say that this is immune to critiques. For instance, nominal rigidities also have their own critiques, but at least that it sort of follows from more this tradition of building models from the ground up, kind of using completely like sort of standard micro foundations for everything. And so I think that is kind of the distinction. But I have to admit that I haven't read this literature just as well, so to be able to kind of tell the subtle differences. But certainly the themes are similar, and I think the methods are different.
Thanks.
I have two questions. Adrien, you are a second generation of Keynesian, yes? In your opinion, what about in the United States the situation with the first generations? In line with Mankiw, who said that macroeconomics must have the real world and models more simple. And what do you say about that? How do you see this is? How is the state of the art in your country about these topics and about these models? Not because the models are progressively more used and are complicated. They are complicated, but they are useful. So more in line with Lucas, no? That Lucas says that we need the models such as if they were a laboratory to see the policy, no? What do you think about this?
Yeah, so it's a great question. I mean, so I would almost say that there were three generations of New Keynesians. There's like Mankiw, Romer. There was sort of the early papers that were more stylized papers that were thinking about mechanisms and questions of when can, say, small nominal rigidities generate big aggregate effects. So it was more qualitative. And even say Blanchard and Kiyotaki, like the very beginning of the New Keynesian literature. And then there was a second generation that was, let's say, Gali, Woodford, Cristiano Eichenbaum, and co-authors. So those were models where they basically had the ingredients of quantitative models, and then they started taking these models to aggregate data, to think about policy counterfactuals. So kind of as in Lucas, robust to Lucas critique, policy counterfactuals. So inside models say, what is the effect of a monetary policy shock? But we want that to be sort of quantitatively realistic, right? Which was not the objective of the first generation. And so there was a lot more realism on the quantitative side, but the quantitative side addressed to macro data, right? So it was can we fit the behavior of macro aggregates? And then I would say there's kind of like this third wave, like Henk is more like a third wave, where the objective is certainly to match the macro data, but to match it for the right reasons at the micro level. And so there's a lot more connection in this kind of third wave to the micro realism, and recognizing that there's all this heterogeneity at the micro level, and also that we can learn a lot from micro studies, like empirical studies that say look at the behavior of consumption in response to transfers. That's what identified using causal methods, so using the credibility of revolution type methods. And so that is kind of, I think, where like the tradition I'm starting from, which is thinking we need to learn a lot from the micro data, and then by doing that, we can be more realistic about our macro predictions. So I'll give you the example of intertemporal substitution. Intertemporal substitution is something that a lot of people at the micro level don't really think is there for things like non-durable goods. There's not that much evidence for it. But in the Cristiano-Eichenbaum type of models, intertemporal substitution is all of it. There's nothing else, right? And now once you say, I can take into account at the micro level all this heterogeneity, you realize you don't necessarily need that much intertemporal substitution in non-durable consumption to get aggregate effects of monetary policy, because you have new mechanisms. You have sort of redistribution effects. So yeah, that's what I would say is it's quantitative, like in the second generation of new Keynesian models, but quantitative more paying attention to the micro data. And so that is what is very different. But it builds on all the other work that came before. So it builds on Lucas, it builds on Mankiw, it builds on Ben-Shal-Kiyotaki, Cristiano-Eichenbaum, Gali, Woodford. So it's just paying attention to some different features of the data.
From Manuel. Manuel, ¿quieres preguntar?
Yeah, sorry, I didn't hear. Yeah, no, my other question is pretty simple. It's more like a curiosity that I have, that, in the standard mutation literature, it was all about Calvo pricing, and partly due to taking the model to data with Calvo pricing seems like a more, I don't know, a more usable framework, a more easier framework. But there's been in this literature of heterogeneous agents like kind of a revival of Rothenberg pricing, like in Kaplan, Moll, and Violante. And what I wonder is why? Why is the reason for changing the usual micro foundation for pricing?
Yeah, that's a good question. I mean, I think that the answer is these models focus on aggregate demand and not on pricing. And so if you're gonna do something simple that delivers a simple Phillips curve, Rothenberg is easier. The goal is just to get a Phillips curve, not to kind of dig into the micro foundations, and certainly not to look at the micro data. So my colleague here, Pete Clino, he's worked for a long time on the micro data from the consumer price index. So he knows Rothenberg pricing doesn't work at all. He says Calvo maybe, and sort of menu cost models, like these more advanced models, they have a chance of matching the data, but Rothenberg has no chance. It has all these implications of very small, very frequent price changes, which you don't see. You see very large, very infrequent price changes. So I think it's just a question of focus. So these models say we're going to be very serious and very careful about the aggregate demand side of the economy, modeling the consumption decisions. There's also work on investment that is very careful about that side, but forgetting about the price setting side. It's kind of a different block of the model, and it's just so looking at different data, but it's not incompatible. And by the way, the sequence space approach that I mentioned, this is something that can allow you in principle to merge in a Henk model for aggregate demand with a lot of heterogeneity and consumption to a price setting model that has a lot of richness on the price setting side, like say menu cost models, of the latest generations, like Alvarez and co-authors, that can match a bunch of kurtosis moments of the micro price change data. So you can totally combine them, and in fact, it's kind of easy to do. So it depends on your focus, and yeah, I would say that that's just the main reason. It's just simplicity.
Right, thanks.
Okay. If there are no further questions.
Please,
Yes.
to finish. We are going to read now the general theory of Keynes. Can you tell us, being you a Keynesian, can you tell us something interesting about Keynes, his general theory, and can you tell?
I mean, I think we're rediscovering a lot of Keynes's ideas. I read the general theory back in graduate school. I was very fascinated by it because it has many ideas that are very powerful. Things like the paradox of thrift and, the importance of income consumption feedbacks and so on. And so I think that, I don't think that he would look at the Hank models and think they're very different from what he thought. He might appreciate some aspects of it. He might also think that there's too much formalism in others. So I don't know, but I'd say that there's a lot of the old ideas that are reviving, in these models. And in fact, I'll tell you a funny anecdote. When I started working with these models, I discovered this result. So this was basically just working on the computer. I said, oh, I have my model and I want to know what's the effect of balanced budget fiscal policy. And I was like, oh, how can it be possible? It's just exactly the same thing as government spending. And then I thought this was a new result. So then I went to Europe and I presented it in front of Morten Raven. And he said, that's not a new result. No, sorry, I actually presented it first at a different at Queen Mary, and people said, "Oh, it's a Havelmo." It's not a new result. It was already known since 1945. And then I presented to Morten Raven, and Morten said, "Actually, the Havelmo result was in econometric in 1945, but it was published in Danish by this guy Gelting in 1941. So this had been invented even before." And so, so I kind of rediscovered 80 years later something that was already there from way, way before. So, sometimes you just come full circle.
Thank you, Adrien.
Thank you very much.
Okay, Adrien, we let you free to go now, and thanks for sharing your knowledge with us, and we hope to engage you for further interactions.
That sounds great. Yeah, feel free to reach out to me if you have any more questions. And it was, great to meet everybody. And thank you for all the very good questions.
Okay, last applause.
Thank you.
Bye.
Bye.
Bye. Take care. Bye.
Carla es muy técnico. No dio la historia. Casi igual. además una buena disposición para,
Sí,
para esto.
pues vos que te han
Claro, una consulta.
Ah. Bien.
Quiero preguntar, con crear áreas, si en algún momento comienza algún espacio. Te comento, yo tengo el interés de seguir haciendo posgrado, sería y la Buenos Aires y la